Welcome to this explainer. Today we're diving into one of the absolute most terrifying, mind-bending thought experiments in planetary science. We're doing a sort of planetary post-mortem, basically breaking down the mechanics of our world by imagining its sudden violent end.
The core question here is actually pretty simple, yet deeply profound. What if Earth just stopped? We're going to imagine the impossible today and look at exactly what happens to our oceans, our land masses, the climate, and, well, us, if our planet, without any warning whatsoever, just slams on the brakes.
Now, before we get to the disaster part, you really need to wrap your head around our current state, which is defined by this crazy number right here, 1,670. Right now, if you're at the equator, you, me, and literally everything around us are hurtling eastward at 1,670 kilometers per hour. That is actually faster than the speed of sound. Crazy, right? You feel perfectly still, sure, but that's only because the oceans, the mountains, the atmosphere, the whole shebang is moving at that exact same incredible speed along with you.
Section 1. The immediate catastrophe. Let's look at those first few seconds.
The sequence of events here is just unimaginable, and it's driven entirely by inertia. So instantly, the ground and the bedrock beneath your feet lock right into place. But in the seconds that follow, the atmosphere, the oceans, and anything not bolted down to the Earth's crust completely maintains that roughly 1,000 mile-per-hour eastward momentum. Within minutes, you've got oceans surging across continents as these absolute mega tsunamis, wiping out coastal regions on a scale we can't even fathom.
I mean, the unleashed kinetic force would be downright apocalyptic. We're talking buildings collapsing instantly under the sudden massive stress. Vehicles picked up and thrown around like little plastic toys. Entire forests just completely flattened in the blink of an eye. And the atmosphere itself would literally sweep across the land masses, generating winds that would completely dwarf the most powerful hurricanes ever recorded. It is total, absolute devastation within mere minutes.
Moving on to Section 2, a dramatically different Earth. This is how we're reshaping our world.
So without rotation, our geography undergoes this massive oceanic redistribution. Right now, our spinning motion creates this centrifugal force, kind of causing water to bulge out around the equator. Well, once that spin stops, gravity totally takes over. The water naturally starts to migrate toward the poles. And what this does is cause the equator to effectively drain, transforming it into this vast, dry supercontinent, while the polar regions just get completely swallowed up by massive, incredibly deep oceans.
Next up is Section 3, Extreme Climate Shifts. We're looking at a brand new planetary climate.
Okay, so Earth is still continuing to orbit the Sun, right? But without spinning on its axis, a single day effectively lasts an entire year. Let that sink in. The sun-facing side of the planet is just baked in months and months of continuous, scorching daylight. Conversely, the dark side is plunged into an endless night of deep, brutal, freezing cold. So we're basically left with two radically opposed, incredibly hostile environments sitting right there on a single sphere.
And this loss of rotation, it entirely reorganizes our climate zones and triggers a massive system collapse. Because Earth's spin, well, specifically the Coriolis effect, drives our global winds, its absence makes weather systems entirely unpredictable. Storms become violently extreme, and under these highly volatile conditions, agriculture completely fails. I mean, it's a wrap. This makes huge portions of the planet totally uninhabitable, essentially collapsing global ecosystems as we know them.
Yet, despite all of this, humanity has a really stubborn habit of surviving. We would basically be forced to relocate to the only stable real estate left on the planet, this narrow little strip of permanent twilight sandwiched right between the boiling dayside and the frozen nightside. There, you'd likely see new, domed cities emerge, relying heavily on advanced technology to artificially manage our food and water. So yeah, we'd survive, but we'd be living on a very, very different, heavily engineered world.
All right, Section 4, the reality check. Let's look at whether this is actually possible.
Ultimately, it all comes down to kinetic energy, which is just the energy an object possesses due to its motion. The sheer, utterly incomprehensible volume of energy contained in Earth's spin means no known natural process could ever bring it to a sudden halt. Actually, stopping it instantly would require a counterforce unlike literally anything in the known universe. So physically speaking, this scenario is totally impossible. You can breathe a sigh of relief.
So you might be wondering, why do scientists even bother exploring it? Well, because imagining the absence of rotation highlights its profound absolute importance. It shows us exactly how our spin shapes our weather, how it controls our oceans, dictates the climate, and naturally regulates our very experience of time. It really forces us to appreciate the massive, unseen mechanics that quietly sustain us every single day.
Which brings us to this really powerful thought. How many of the systems that keep our world stable are quietly working in the background without us ever even noticing? The next time you're outside watching a sunrise, just remember that you are a passenger on a multi-trillion-ton ship, spinning at supersonic speeds. If a simple spin dictates so much of our existence, what other invisible cosmic forces are quietly holding our reality together right now? It's definitely something to think about.